Okay, students, here we're talking about lesson 2.4. And we're moving from 2 sets to 3 sets. And we're still doing the Venn diagrams. And we're going to do set operations. By the way, the introduction here had a really good presentation on the idea of the food that you eat and how it may or may not be related to your blood type. So that's important, especially for people who may become what's called pre-diabetic. All right, so let's begin our work. We'll take it one step at a time. Let's begin with example 1. Now, if you would notice here I have the universal. I have the elements in set A, the elements in set B, and the elements in set C. Again, please try to remember our goal is not numbers and sets. Our goal is organizing our thinking, but this will help our thinking later in a very big way. Now, let's do this first part A. It may help to sort of rewrite it. So let me just use a different color here. What does it mean? A union B intersect C. That's very interesting. Remember, we're going to do the inside parentheses first. So let's do B intersect C. So the question really is, what elements are common with B and C? Let's see. One easy way to do this is to pick one of them, B or C, and then use that to look at the other one. So for example, I'm looking at this 1 right here, and I'm looking in set C and see if there's a 1. So watch what I do. I'm looking at set B. 1 is not in C. 2 is in C, so they're common. 1, 2, 3. 3 is in C. 6 is in C, and 8 is not. So this part right here is B intersects C. Now remember, I have to do the union of that and A. Remember, A is 1, 2, 3, 4, ran out of room, 5. Sorry, that was a little sloppy. 1, 2, 3, 4, 5. Now, union. Union means I need one of every element. So I'm going to start with the left one. 1, 2, 3, 4, 5. Now, I already have a 2, I already have a 3, but I need a 6. So 6. So folks, this is your final answer for question A. Okay? Now let me try my best to see if I could erase. Oh, did not want to do that. Okay, so that's we could probably erase this. Let's go to B. B. Now, what is B saying? Well, B is saying it's an intersection of, the left is A union B. Remember, A union B is 1, 2, 3, 4, 5. Okay, now let's see, B, again, here we go, B, 1, 2, 3, 6, 8. 1, 2, 3, 6, and 8. This is A union B. And we need to do A union C. A union C. Again, what I do is I look at A. A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then C, 2, 3, 2, 3, 4, 6, and 7. Okay. Now, there are other ways to do this, but this is a way that I feel most people can understand. Now, intersect means what? And. What's in common with both of them? So remember, intersect means and union means or. All right, what's in common? I've got a 1, I've got a 2, I've got a 3, I've got a 4, I've got a 5, I've got a 6. Now, is 7 common? No. Is 8 common? No. So that's it. All right, so that's the answer for B. Okay, I hope that makes sense to you. Not too difficult. All right, now let's move on to the last part. The last part here is related to this section. All right, so what is that, again, what is that answering? Sometimes it helps to rewrite the problem. It's kind of like putting it in your program, put it in your computer. So it's an intersection, but it's an intersection of A and the union of B and not C. So this is a little complicated. What I'm gonna do is I'm just gonna put this intersection here, and I'm gonna go and write A. 1, 2, 3, 4, 5. Okay, now what I need to do, B union, I'm gonna go like this. B, 1, 2, 3, 6 and 8. Okay, there's B. Union C prime. Now, what is C prime? C prime is everybody that's in U that is not in C. Everybody that's in U that's not in C. Well, 2's in C, 3's in C, 4's in C, 6 is in C, and 7 is in C. So what's in U that is not in C? Looks like 1, 5, 8, and 9. Now, folks, it's going to take you a little time to get used to doing these problems, but once you do it, it will help you. And again, that's part of the purpose of the course. Now, let's do this union. The union is I need everybody together in one meeting. So I need all of the members. Well, I've got 1, 2, 3. Do I have a 4 over there? No, but I have a 5, 6, no 7. I've got an 8 and I got a 9. Try to remember the way I discussed this with clubs, like Greek clubs at the college. And again, we have the 1, 2, 3, 4, 5. Okay, now, the intersection means what's in this set right here and that set. I'm going to look over here and compare the 1. Is there a 1 on the right side? Yes, so 1, 2, 3. Let's see, and I have a 5. And look, I ran out of elements here to compare. So that gives you some advice. Pick the one that's smaller when you do an intersection. Okay, this is the answer for part C. So keep that in mind. All right, let's see. What do I want to do next? I think what I need to do is do a little teaching here on regions. Let me do this. So I'm going to draw a U. And then what I'm going to do is I'm going to try to draw a and a B. So again, this is U, this is A, and this is B. Now what I'm going to do is I'm going to, just for the sake of argument, I'm going to label the regions. I'm going to call that region 1, region 2, and region 3, not regions bank. Okay, there you go, region 4. Okay. Now notice I have all the portions or the regions of the universal shaded. My question is simply this: how would I describe region 1? Well, I could say you're in circle A minus anybody in B. I want no B. I could do that. Or I could say it A union not B. Okay? Now, that's a little counterintuitive because you want the union of something that's not. But what you're saying is A union not B. That is not true. A union not B. You really want, I've got this wrong. I'm going to have to give you price of your tuition back here if I make a lot of mistakes. This is A intersect, not B. So remember, not B is everybody outside of the circle. And what's common with everybody outside of this circle is this part right here. Just kind of let that settle in your mind, see if that works. Let's talk about region 2. All right, so we know this is the intersection of A and B. That makes sense. Okay, what's common to A and B? Let's try region 3. Essentially, it's region 3 is everybody in circle B, but not in A. So B minus A. Now, a way to describe this would be, I want B, and I want everybody, I don't want any part of A. So I could say B intersect not A. Now remember, what is not A? Not A is everybody outside of A and that includes this region right here. That may be a little confusing. It is to me a little bit. All right, how would you describe region 4? Region 4 is the whole U minus what? What's in A and B. That would be a union of A and B. Another easier way to say that would be A union B, the complement. Everybody outside of A and B. Okay, now I hope that made sense. That should make sense. All right, now let's see what I want to do. Okay, let's try this with 3 sets. And let's this time let's just try to talk about it. Okay, so here's my union, and we're going to try to put 3 circles in here. Okay, kind of like an Olympics with 3 countries. Let's use a different color. Now don't forget, this is set A, set B, set C, and then I'm going to put U right here. Remember, U is everybody inside the playground. let's also talk about region. So let's put 1, 2, 3, 4, 5, 6, 7. Seems like I got one more region to do. Oh yeah, the region down here. So I'll just go over here and say 8. Okay, so there you go. Now you have all the regions. Question: how would I describe region 5? That's a good question. So let's do that. Region 5 would be where everybody, I'm in all of the sets. So that would be A intersect B intersect C. Does that make sense? How would I show everybody outside the circles? Outside the circles. That's a good question. So well, that would be everybody not included in the circle. So in the circles would be A union B union C. But if I want to show outside that, I would do prime. Now, I hope that helps you. Now, what I'm going to do is I'm going to try, and I use the word carefully, I'm going to try to look into your textbook and see if we could look at this example. So here I have the region set up properly, and here I have, how would I describe this? So do take some time and look at this. Let's look at region 2. Region 2. Now remember region 2, hold on here. Region 2 is this region right here. So it's everybody that's in A and B, but not in C. So region 2. This region represents elements both in set A and B that are not in C. Now one way to explain this, if you notice what I'm doing here, is A intersect B intersect not C. You could think of that as doing away with C. Maybe that makes sense. Intersect not C. Okay. We may need to think about that some more. All right. So on your in your textbook, there's the rest of the regions here. Okay. So you got regions in white, regions in light blue, regions in dark blue. Take a look at that, and we'll talk about that on Friday if we need to. Now it's time to do another problem. So let's do example 1 we already did. Let's try example 2. All right, example 2. Now notice in this diagram, we have the 3 sets in the universal. I have my regions that are identified, and I have the colors, and I have problems, A, B, C, D, and E. Let's look at A together right now. Here's A. All right, A says, tell me what A is. Tell me everybody in A. Okay, well, I've got regions 1, 2, 5, and 4, correct? Now, you don't have to have them in order. Sometimes I like to write them in that order. But I want to know the exact elements. So what are they? 11, 3, 12, 5, 7, and 6. Okay, see how I did that? That's important. All right, let's try the second one, A union B. Okay, well, let's identify the regions. A union B. I've got 1. I've got all the others in A, which is 2, 4, and 5. They're all in A. And B. Well, I've got everything, I've got all of this circle here except the light blue part and the white part. So I'm going to need to add 3, and I'm going to need to add 6. Okay? So there you go. Those are all of the regions for A union B. Now let's actually put all of the numbers. So A union B, well, I need a 3, need an 11, need a 6, need a 5, a 7, a 12. How about that 9, right? I need that. And then 1, 2, and 10. Okay, this would be all of the elements in A union B. That's a mouthful right there. All right, let's try this one. Question C says B intersects C. So here's circle B and here's circle C. Intersect means what's common, so it's this region right here. And what is in region 5 and 6? Well, we have the elements 5, 7, and 9. Okay? That's helpful information. Now let's try another problem. Not C. Not C. Well, this means every region that's not in C. So here's C right here. That would be what? 1, 2, 3. Not in C. And 8. That makes sense? 1, 2, and 3, and 8. And then you can name the elements, okay? I think, I'm pretty sure you know how to do that. All right, let's look at that last one. A intersect B intersect C. Now, we've already talked about that before. That's this region right here that includes everybody. Includes everybody. It's very easy to know who's inside versus who's outside. So what region is that? It's region 5. What are the elements? 5 and 7. Okay, I forgot to put this in sets, but there you go. That's how I would do example 2. It's very important that you know how to do that example. Okay, now we have actually one more problem, and it's example 3. And I have to figure out how I'm going to get this information to you. So hold on here. Let's see. Now, if you notice, that last set really did take a while for the author to explain. Okay, this is what I want to give you. This is the question that I want to go over with you. So I need to kind of figure out how to do this. You're going to have to I thought I had this somewhere, but okay. Again, I do apologize for all of the time it takes to do this, but there we go. We got it. I think we have it taken care of. So let's get going. Let's get rid of this here. Okay. Now, the question says, construct a Venn diagram illustrating the following sets. Basically, if you'll just remember one thing, it'll help you to do this. Always start with what's inside first. So the first thing we're going to do is draw a picture. Okay, don't forget you have your three nations in the Olympics. A, B, and C. Sorry about the squirrely letters there. Drawing. Okay, don't forget this is U. All right, number one. Notice U includes all the letters A, B, C, D, E, F, G, H, I, G, A, H, I, J, K, L. All right. First thing we're going to do is this region right here. Let me get a different color. Here we go. All right, this region right here in the middle, which is what's in common with all of them. Use a little shortcut. Take the letters that have the smallest number or the set with the smallest cardinality. A, C, E, H. Is A in all of them? No. Is C in all of them? No. Is E in all of them? Here, here, and here? Yes. Is H in all of them? Here, here, and here. So the answer is E and H. E goes here, and H goes here. Now, we're going to look, and I'll just color it in, this region right here. Now, what is that? It's what's common to A and B that is not E and H. So I'm up here looking at A and B. Okay, what's common? Well, let's see. Let's take the small one, right? No B. We have E is common. Is G common? Chi is common. Is H common? Yes. Is L common? No. Now, I've already got E and H down here, so I need to add G. I need to add G. I'm going to put a G right here. Okay. Now, let me shade another region here, okay? We want to figure out what this region is, okay? Well, what is that region? It's A, intersection of A and C, but not E and H. A and C. A and C, okay? All right, well, let's see. What are those? What is the intersection? Let's start with the C. So that's going to be A, right? No C, but we have an E and we have an H. So according to this information, we already got E and H here, so we need the A. A goes right here. All right, now that may seem tedious, but it is going to be helpful to you later on, so keep that in mind. All right, now let's look in this region. This region right here. What is in this region? Well, it's B and C, but not E and H. B and C, but not E and H. What are those? Well, we'll start with the smaller one. A, no. C, no. E, yes. H, yes. Well, we already have E and H, so we're just going to leave that blank. Okay, now we're going to have to figure out this region right here, which is A, that does not include A, E, H, and G. So again, it's A that does not include A, G, and E and H. And what are those letters? Those letters are D, I, and J. Okay. All right, let's look at B. B, I've got a G, E, and H. G, E, and H. What's left over? What's left over is B and L. All right, let's figure out C. A-C-E-H. A-C-E-H. I just need a C. Okay. And that seems like a lot of work. We're almost done. Okay, now we need to know, are there any elements out here in U? Well, let's cross off what we have. We took care of the A, we took care of the B, we took care of the C, we took care of the D, we took care of the E, took care of the, oh, I don't see an F. Let's put an F there. We've got a G and an H taken care of. We got the I, we got the J. I don't see a K. So K goes over here too. And then we have an L. Okay? So this is how you write the organizational graphic of a set given the information in a roster form. So I hope that helps you out. I'll have to do another video on the proving of the sets. So we're just going to stop right there with that one.